All right, we're back in part 2 of my mega C++ tutorial. You may notice I am using a different text editor here. I was using C-Line for the first part, but I also wanted to demonstrate how you could use some other text editors. One I use also is Sublime Text. So we can use this to run our C++ programs as well. In the intro of this, once I build this program together, I'm going to talk about a little bit about the different environments that you can use to run C++ programs. So if you're watching this in the real put together mega tutorial, you'll probably have already seen that you can run it with different environments. Okay, so we're going to start off by creating a file, and I'm going to save this file as classes intro. Let me go here. And I don't want to show my hidden files here because you don't really need to see them. We're going to solve them in here, or we're going to save the file in here. And we're going to call this 042 classes, classes intro.c++. Okay. And so now I can make some comments at the top, just like I've done before. Created by Timothy Unkert on, this is going to be the 2nd of November. And I'm going to show you a different way to comment in our next file. But so what we're going to do is we're going to include our IO stream here. And we're going to define, if I can spell it right, define our constant pi, because I'm going to use that later, and I'm going to define it as 3.1241592. We're going to say that we're using the namespace. That's not the right snippet. Sublime has some different snippets, so I just want to say namespace standard. It's going to look through this folder once I start defining it and give me some shortcuts. So if you see me tabbing and getting stuff quickly, that's why. Okay, and to create a class, what we're going to do is use the keyword class, and then we're going to name the class, and the convention is to name it with uppercase. And I'm going to give basically a member of the class, which is going to be the radius. Okay, so we're going to have a sphere, we're going to have the radius. And then I can do public, private, or protected, and some methods. I want to make my methods public, okay, not namespace, just public. And I'm going to say one is void and or returns nothing, right? And I'm going to call it set radius, and it's going to take in a double. And now what I'm doing here, this is kind of like a function prototype where we just say, okay, it's going to take in a double, and I'm actually going to define the set radius outside of this class. So you'll watch me do that in a moment. And then we'll have another method that's public. This will return a double. It'll be volume, and it's constant function. And we're going to return 4.0 times pi divided by 3 times radius times radius times radius. Okay, so if you don't know the formula for the volume of the sphere, it is 4/3 pi r cubed. That's why I'm multiplying by the radius 3 times. Okay. All right, so now what we're going to do is we're going to go down here, and we are going to go, so we're outside the class, and actually right at the end of the class, I'm getting this little warning. I have a package called Sublime Linter GCC installed, and that gives me a warning. I have to put a semicolon here at the end of this class, so make sure to do that. And I'm going to create a function. It's going to be void. I'm going to give the name of the class, so sphere, and then 2 colons, and set radius. You might have remembered this from std : cout before. It's basically what this is. We'll say it's a double R. Okay, and let's open up the function. I want to make a comment up here, And my comment is going to be that the double colons, it's called a scope separator. So that equals a scope operator. Okay. And what that basically does is it defines a member of a class outside of the class itself. Okay. So for instance, in this case, we want to be able to set the radius, right? So we're going to say radius equals this r, okay? So we'll set this later on once we create our class, okay? And now I'm going to go down and create my main function. So I'm going to say int main. Now the other thing that's kind of cool with Sublime Text is it has this shortcut. You type main and it kind of gives it all to you. And now this is for command line arguments. I'm not really going to cover this in this tutorial, so we'll just get rid of this stuff. But so we have our int main here, and what we're going to do is basically create an instance of the class sphere. So we're going to type the class name sphere, and then what we want to call this class. So we're going to say my sphere, because I'm really creative with names. And then I'm going to put an open and closing curly braces and a semicolon. So now I've created, let's make a comment. I've created an instance of the sphere class. Okay. All right. So now what I'm going to do is I'm going to say my sphere dot, and I have a method set radius. Okay. And now I'm going to set the radius at 5 units. Okay. So now I can use the volume method because I have a radius that I've set using this method we've declared, which is a member of this class, even though we've declared it outside of this class because we use the scope separator here, or scope operator. I need coffee. Scope operator here. We use that, okay, to define a member of the class outside of the class itself. Okay, so what I'm going to do is a character output, and I'm going to say the volume of my sphere is, and I'm going to say my sphere dot volume, and then I'm going to just end this with a period and /n for new line and put a semicolon there. And what I can do now is I can open up another tab, and to run this, I've just been running it through the IDE up to this point. To run it, what I'm going to do is I have this thing called terminus, which will open a terminal shell in the other tab. So you'll see that's highlighted here. I'm just going to do that. And what I can do to run this is just G++, and then the name of the file, which is 042. I'm going to hit tab to autocomplete it. And well, this is going to compile. It's not going to run. This is going to create an output file called a.out. Okay. And to run that, I can do a period / and then a.out. Okay. And you see here, the volume of my sphere is 523.599. Okay. Now to close this out, I can do Control D and just close that out. Okay. So what I can also do now is create another instance of the sphere. So I'm going to type the name of the class, sphere, and I'm going to name it your sphere because I am original. All right. And we're going to put a left and a right closing curly brackets, a semicolon. Okay. So now what I can do is type your sphere dot set radius and 9.8. That's because we can put it as a double, and I just wrote down 9.8. So that's what we're going to do, 9.8 units. And now we can also use this to output the volume of your sphere. So we can say the volume of your sphere is, and then we're going to do your sphere dot volume. We need those open and close parentheses there, and we'll do period / n there. Okay. And let's just close out the sidebar so you can get a little bit better view. We'll save the file, open the default terminal, And we'll compile. And I'm just pressing the up key to get back to my previous commands, and then we'll run it. And we can see the volume of my sphere is this, and the volume of your sphere, because remember we used 9.8, which is greater than 5, so we got a much bigger volume because we're cubing it. So that's 3,942.46. Okay, let's close that out. All right, now let's see, what did I want to talk about next? So next, what I wanted to talk about is constructors in classes. Okay, so we're going to create a new file. I'm going to save this as 043 constructors.c++. Okay, and I'm going to make a comment a little bit different way at the top. So sometimes, especially in C programs, C++ is a superset of C. You might see something like this, where you see this multi-line comment this way. So I have author is Timothy Unkert. Then you might have something like the purpose of the program, demonstrate the use of constructors in classes, and then you might see like a date. Here, in this case, it's the 2nd of November. And then to end the comment, we do an asterisk and then the slash here. Okay. And so what I'm going to do now is just move on to the file. I'm going to type include iostream here. And then I'm also going to define pi for this file. So I'm going to type define pi. We'll do 3.14, 1592. And we'll say that we're using the standard namespace here. Notice how Sublime, now that I've used these words in my previous file, it's picking up on the same words in the same folder, and it's so I can just tab and complete that. Okay, I'm going to focus on this sphere class like we did in the prior example. So I'm going to say class sphere. We're going to have a double of radius. And then we're going to have a public, and I'm going to say this is explicit, so only for the sphere. We're going to have a double here. And so that's going to be kind of like that function prototype we talked about before. Let's make sure we get the semicolon there. And I'm also going to have just the double volume constant function here, and we're going to return 4 times pi divided by 3 times radius times radius times radius. Okay. All right, and then we'll go down here and we'll use our constructor. And the way we can do this, let me scroll up. We're going to type sphere colon sphere. Okay. Because we have this sphere right here, right? And then we're going to say double R, and we're going to say radius equals R, okay? So we've created our constructor, and let's make a comment. This is my constructor. So this is my constructor, and this is called, it's called when a new object is created. Okay. All right. So it's a little different in how we can declare a new instance of the sphere class. So I'm going to create a main function here. And within that, I'm going to say sphere and my sphere. And I'm going to just put 2 parentheses right now and just give my radius of my sphere. And let's say it's 5.2. Okay, and we created a new instance of the sphere class and set the radius. Okay, so we did that all at once, right, with the constructor. So now I can do a character output, and I can say the volume of my sphere is, and I can say my sphere dot volume. Okay, call that method, and just do a period and a new line character here at the end, and then return 0. at the end of this main method. Okay, so now I'm going to open up default shell terminal here, and I can type G++ and then 043. And this is going to overwrite that output file, okay, with the content that's in file 43. Okay, and so now to run this, I'm going to run that output file, which again has been overwritten with the content in file 43. Okay, so we see the volume of my sphere is 588.977. Okay. And again, we can create another sphere using this. So we can type sphere and then another sphere. And let's make it a small one. So we'll make it a radius of 0.24. Okay, so we created another instance of the sphere class here and gave it a volume. And we'll do a character output, and we'll say the volume of my other sphere is, and we're going to do another sphere dot volume, and see if I'll just show you something. Dot, okay, and we see that it's noticing that volume is a function here. That's where the F is coming from. So we're going to do dot volume, which a function inside of a class is called a method. Okay, so if you're wondering about the switching of the terminology there, and sometimes I'll say, oh, the main method, it's main function, but you can sometimes interchange those words. But technically, main function, volume method. Okay, all right. So now let's open up our tab, and we're going to do G++ 043. I'm going to hit tab to autocomplete that. And then to run this, we run the output file. Okay. And we see that the volume of the second sphere is much smaller because we had a radius less than 1. Okay. All right. So that's constructors. And next up, I wanted to talk about having some default constructors. So a little bit more about constructors, default parameters as well. So let's make a new file. Let's call this 044 underscore default underscore constructors .c++. Okay. And we can just say this is created by Timothy Unkert on the 2nd of November. And now what I can do is I can include my header file, iostream, specify what namespace I'm using, and let's create another class. This time I'm going to move from a sphere to a cube. So we're going to say class cube, and I'm just going to do an integer of the side. And then we'll do a public. We'll declare the public methods. And so we're going to have an empty cube method here. And then I'm going to take a pause for a moment because I have to do something with the power of editing. I'm going to be right back. All right, I'm back now. And so this is going to be for the default constructor here. And now we want to have basically one for the constructor where we actually are entering different inputs. So we're going to have one integer come in here. And then we're going to create a function for volume that returns an integer. So we're going to say int volume. Let's make it a constant function here. And we're going to return here it's just going to be side times side times side. Okay. All right. And we'll have a semicolon at the end here to end our class. And let's create the default constructor. So I'm going to type cube, 2 colons, cube, and then just open and close parentheses here. And we're going to say that the side equals 2, okay? And that's going to be the default parameter. So this is the default constructor, okay? Now I'm going to go down here, and I'm going to say cube, colon, colon, cube, and I'm going to have an integer s, and I'm going to say side equals s, okay? All right, so now I'm going to create my main function. So I'm going to select int main, and you'll notice here in a previous video, previous file actually, I went down here and let me show you. I typed main and hit tab, and this is what Sublime gave me. And I deleted out that and went about my business writing my code, right? Well, you notice the style is slightly different here. I've been doing it this way. Some people in C++, they code with it this way, with the curly braces on a separate line. Doesn't really matter. You do want to be consistent. I noticed in the previous file I did have my methods like this, and then I had my main function like that. So anyways, whichever method you pick, keep it consistent. Okay, so now that I've created my main function, I want to create an instance of the cube class, and I'm just going to say cube my cube. Okay, now when I do it this way, the default constructor is called. Okay, so if I do a character output and say the volume of my cube is, it's going to take that value of 2, the default value that I set up there, and it's going to use that to calculate the volume. So I'm going to say my cube dot volume, okay, and we'll put a period, a slash n there at the end, okay. I'm going to save this. Let's open up the terminal here. We'll do G++. I think we're on file 44, default constructors. Again, that's overwriting the output file. So then we'll run it, and we see the default, or the volume of my cube is 8. That's 2 times 2 times 2, okay? So it's taking that default value of 2 here, okay? Now I can also create another cube, so I can, or another instance of the cube class. I'm going to call this my other cube, and this time I'm going to, instead of curly braces, pass in the values, or pass in one value. Let's say 10, okay? All right, so now I can do a console out, not console out, character output. The volume of my other cube is, and then I'm going to do my other cube dot volume, and do a period and a slash n there. Now, if I run this, we should get the volume for the second one of 1000, because I put in the side of 10. So I'm going to do G++, 044. We have to recompile it each time. We want to rerun this. Each time we make a change to the program. All right, so I'm going to run this and see the volume of the first cube. It takes in the default side of 2. The second one, it took in the side of 10. So 10 times 10 times 10 is 1000. Okay, whereas 2 times 2 times 2 is just 8. That's how I'm getting those numbers. Okay, so this is not calling the default constructor. This is calling this constructor here. Okay, let's create one more instance of the cube class. So I'm going to say yet another cube. I'm going to show you one other way to do it. And I'm just going to put an open and close curly braces and a semicolon. Now, the default constructor in this case is called again. And so I'm going to say character out and say the volume of yet another cube is yet another cube dot volume, and we'll put a period and a new line character. Now, with this file in GitHub, if you look it up, I'm going to have width, length, and height, because I was not thinking cube, I was thinking rectangular prism, so it doesn't quite make sense. But since I'm choosing cube here, cube only has one side. It's, or one side, all the side lengths are equal in a cube. Okay, so really, the GitHub example is going to be more of a rectangular prism example, but it's probably good to see both. All right, so let's open up the terminal. Let's recompile and rerun, and we see the volume of yet another cube. Again, it's taking the default side of 2, so 2 times 2 times 2, it's giving me 8. Okay, so that's default constructors. So let's see what up is next. What is up next? All right, so let's go to other ways to initialize classes. So I'm going to create a new file. I'm going to save this as 045, and we'll call this other ways to initialize .c++. Okay, and I'm just going to make a comment created by Timothy Unkert on 11/2/22. Okay, and we're going to include our header file, iostream. Okay, we're going to say that we're using the standard namespace. Okay, and let's create a class called cube. Okay, actually, let's call it rectangular prism. Okay, and we're going to have 3 doubles. So we have double, width, length, and height this time. And we're going to have some public methods here. And we're going to, basically, this is another way we can initialize. We can type actually the class rectangular prism, and then say something like double W, double L, double H, and then we can say width equals W, length equals L, and height equals H. Okay, put a semicolon at the end here, and then we'll say double volume, a constant here, it's a constant method, and we'll say return width times length times height. So that's how you return the volume of a rectangular prism. Okay, so that's a different way of doing it than we've done prior. We're going to create our main function, and let's return 0 at the end there. And let's create an instance of the cube class. And I'm going to say cube, my cube. And then within curly braces, I'm going to put 3, 4, 5 for my different length widths. That's one way we can do it. We could also do cube, let's do my other cube. And we could set equal to curly braces, and let's do 6, 7, 8. Okay, just different numbers. The numbers don't really matter. And so this is 2 different ways of initializing it. And we can do a character output here. And I'm typing cube, and it's giving me an error. And I'm like, it's giving me an error. Why is it giving me an error? Because I keep thinking cube and rectangular prism, but no, I should be typing rectangular prism. I could call it my cube, or let's call it my rect, and then also do rectangular prism, my other rect here. Okay, that sounds better. All right, and then we're going to do a character output, and we'll do my rect dot volume, and just do an inline there. And we'll also do character output my other rect dot volume. Okay, and now let's open up a terminal. This is going to be, we're going to be compiling the 45th file here, and then we're going to run the output. Okay, we get 60 for the first one and 336 for the second one. Okay, so that's some different ways to initialize classes. Now I want to talk about pointers in classes. Okay, so let's clear out some of these files here and create a new file. We're going to save this as 046 pointers and classes. .c++. Okay. Again, just make my comment here. Created by Timothy Unkert on the 2nd of November. And we're going to include our header file here. We're going to say what namespace we're using. And let's create a class called cube, class called rectangular prism. And let's have it as integers this time. So we'll have an int width, an int of length, and an int called height. And then let's have some public methods here. And we're going to say, again, rectangular prism. We have, let's just have int A, int B, int C, okay? And we can declare it in even another way here. We can do a colon here and do width, in parentheses A, length, in parentheses B, and then height, in parentheses C. And to end this, we can just do an open and close curly braces like that, okay? That's another way we can basically get the values into this class, okay? Or direct C++ that we're going to take in some values for this class, okay? So I'm also going to have a method called volume that returns an integer, and we're just going to return width times length times height, okay? Put a semicolon at the end of my class, and let's create our main method. So I'm going to do int main, return 0 at the end there, and we're going to have we're going to create, let's create a few different ones. So we're going to do a rectangular prism here. Let's call it myrect. And I'll do lengths of 3, 4, 5. Okay. And then we'll also do a pointer. So let's do rectangular prism. And we're going to do an asterisk here to indicate a pointer. And we're going to say myrect and then LOC for location. Just going to declare it. And I'm going to say my rect location equals the address of my rect, okay? So my rect location equals the address of my rect, so the memory address of my rect. I'm going to do a character output. I'm going to say the memory location of my rect is, and then I'm going to do my rect location, and then just do a new line character there and a semicolon. Let's save this and let's compile and run this. So let's do G++. We are on file 46 here. Again, it's overwriting that output file. I'm going to do a.out here, and we're going to run it, and we see the memory location of the instance of the rectangular prism class. My rect is located at this 0x7ff, etc. Okay. All right, having a little coffee there. Okay. Now we can also use the pointer to find the volume with some kind of cool syntax here. So what we're going to do next, we're going to find the volume of my rect using a pointer. Okay, so we're going to do a character output and say the volume of my cube is, and not my cube, to my rect is, I really want to be doing a cube. We're going to do my rect location. I'm going to do this arrow here, okay, and then volume. Okay, so that's pointing to the volume method. All right, and we're going to do a new line character here, and yeah. So let's save this. And let's open up a terminal. We'll recompile and rerun. And we get the volume of my rect is 60, which makes sense, right? Because we entered 3 times 4 times 5. So 12 times 5 is 60. All right, so that's a little bit about pointers and classes. Another thing I want to talk about is some other ways of class definitions here. All right, so let's create a new file, and I called this file 047 underscore other cool class definitions .c++. Okay, and so what I want to do now, let's make a little comment here. This was created by Timothy Unkert on 11/2/22. Okay, and I'm going to include my header file iostream. I'm going to indicate that I'm using the standard namespace. And we're going to have a class called rectangular prism, although on GitHub I'm putting it as cube for some reason. And let's have some doubles this time. So we're going to have a double width, length, and height. Okay. And let's have some public methods here. So we're going to say rectangular prism. I'm going to say double A, double B, double C, do a colon here, and then say width, parentheses A, length, parentheses B, and height, parentheses C. And again, we'll end this with open and close curly braces, like so. Then I'm going to create a method called volume. So we'll have double. It's going to return a double. We'll call it volume. And we're going to return width times length times height. Okay, and at the end of my class, I'm going to have a semicolon here. Okay, so we can use pointers as a way of defining a class. So let's create our main function here. Return 0 at the end of that. And I'm going to say rectangular prism because I'm creating an instance of the rectangular prism class, but this time a pointer, and I'm going to call it my rect is the pointer. And then I'm going to say my rect equals new rectangular prism. And we'll just do in parentheses, let's do 3, 4, 5. Okay, close that out. And now what we can do is get the volume. We can do a character output. And we can say the volume of my rect is, and we'll say my rect, and do an arrow to the volume. So we'll point to the volume method and just end this with a new line and a semicolon here. Okay, so at the end of this, what we can do is we can use the delete keyword to free up some memory. So we can delete my rect. Okay, so let's now compile this. So we're going to open this up. We're going to do G++, and the name of the file, we're on to file 47. Okay, and we're going to do the output file, and we can see the volume of my rect is 60. So that's one way we could do it. We can also, let's create another instance here, and we'll say rectangular prism because it's going to be part of the rectangular prism class, and we'll say my other rect here, and then I'm going to say my other rect equals new rectangular prism. This time I'm going to make it 2 items here. So, and then in square brackets, we're going to put the number 2. Then we're going to put some curly braces here. And just for formatting, I'm going to give it some space here. And then we're going to have curly braces inside. So the first one's going to be 3, 4, 5. Then I'm going to have a comma. And then the next one, let's do 8, 9, 10. Okay. and we'll put a semicolon at the end here. All right, so now I've created two basically rectangular prisms. Okay, and let's deal with the first object. First object's volume pointed to by my other cube. Okay, scroll this up a little bit. So I can do a character out. I can say the volume of my other cube at index 0 is, okay, so we're kind of like, this is kind of like doing it with arrays. So I'm going to do my other rect. I keep saying cube. My other rect at index 0 dot volume, and do a new line character at the end there. Okay, all right, so let's save this and let's compile and run it. Okay, so the volume of my other rect at index 0 is 60. Okay, so now let's also focus on the second object's volume. So the second object's volume pointed to by my other rect. I keep saying cube. By my other rect. Okay, so what we're going to do is a character output. We'll say the volume of my other rect at index 1 is, and we're going to do my other rect. Where is it? My other rect at index 1 dot volume. Okay, and do a new line character here at the end. Okay, and at the end, what we can do if we want to free up memory is we can delete. So we can do delete and then open and close square brackets like that, and just do my other rect. And this frees up memory. Okay. All right, let's open up a new tab here. And so we recompiled, and now I'm going to go up and rerun. And we can see the volume of my other rect at index 1 is 720 because I entered 8 times 9 times 10. So 8 times 9 is 72. 72 times 10 is 720. So it all works out there. Okay, so that's some other cool ways of doing classes. And let's see, where are we? Oh, let's talk about struct classes. So we can create classes with structs. Okay, so I'm going to do a new file here. I'm going to save this as 048 underscore struct underscore classes dot C++. And let's say created by Timothy Unkert on the 2nd of November. And okay, so we want to include IOStream here. And we want to say that we're using the standard namespace. Okay. And let's create a class with a struct. So I'm going to say struct rectangular prism. And it's going to have a double width, a length, and a height. Okay. And we're going to say rectangular prism. We're doing the same thing we did before, double A, double B, double C, a colon, and we'll say width, parentheses A, length, parentheses B, and height, in parentheses C, and open and close curly braces here. And now by default, the difference with the struct is by default, the members of a struct are public. Okay, so we don't have to use that keyword public. So we're just going to say double volume, but if you want it to be private, by default it's not. So we're going to return width times length times height. Okay, and then we'll put a semicolon to end that off. Okay, we're going to create our main function here. And we're going to say rectangular prism, my rect, and just in parentheses, let's put 3, 4, 5. So I have a volume of 60. Let's just confirm that. We'll do a character output and say the volume of my rect is, we're going to do my rect dot volume and end that with a period and a new line character there. And we'll return 0 at the end of my main function. Okay, I'm going to go up here. Let's recompile, or let's compile this. So this is the 48th file. And then let's run the output file. So we see the volume of my rect is 60. So we can create classes using the keyword struct. Okay. All right, let's go. We're going to create another file here. And I'm going to call this one 049. We're going to talk about recursion. Okay. So we're going to switch gears a little bit. Let me clear this out. So I'm going to save this as 049 underscore recursion dot C++. And I'm going to do a little bit different method for commenting here. I'm going to do the more C-ish way of doing it. So I'm going to say author, Timothy Unkert. And the purpose is to demonstrate recursion, which is a function calling itself. And the date is the 2nd of November. All right, so we're going to include our input-output stream here. And we're going to say that we're using the standard namespace here. And what I want to do is create a function that calculates the factorial of a number. So the factorial of a number, you get that, let's say you have an integer 6. The factorial of 6 would be 6 times 5 times 4 times 3 times 2 times 1. Okay, so that's the function that I'm creating. So I'm going to call this int. It's going to output an integer. It's factorial. It's going to take in an integer. We'll call that num. And we're going to say if the num equals 1, all we're going to do is we're going to return 1. But if it's not 1, we're going to return the number times the function again. So we're going to call the factorial function, but we're just going to decrement the number by 1. So let's say it's 5. We pass in 5 to this function. We go down here. We're going to skip over this if num equals 1 because it's not going to meet this condition. And we're going to return 5 times the factorial of 4, okay, which would be 4 times the factorial of 3. So we're going to keep going down until we hit 1, and then we're just going to multiply all of this by 1. Okay, so this is an example of recursion. Okay, so now I'm going to create my main method. I'm going to say int main. And I'm going to create an integer called n. And we'll give some instruction to the user to enter an integer. And then we'll take in the integer. Okay, and then we'll output the factorial of the integer. So we'll say the factorial of n is, notice how I'm leaving the spaces, and then we're going to call this factorial function, pass in n, and then at the end, we're going to have our new line character, which shouldn't be confused with n because they're different. Okay, and we're going to return 0 at the end of this function. All right, so let's open the default shell here, terminal shell, and this is file, what is this? File 49. Okay, so type 049, I hit tab to autocomplete the file, and I compiled it, and now let's run the output, and we get enter an integer. I'm going to do 5, which should give me 120. So the factorial of 5 is 120. We can just run it again. We could do 10, which is going to be much bigger. Okay, that in that case, that's 3,628,800. Okay, so we can find the factorial using recursion, which is pretty cool. Okay, So now what I want to talk about is encapsulation. Okay. So let's create a new file. And we're going to save this as 050 underscore encapsulation.c++. Okay. I'm going to make a more C-ish comment. The author, that's me, Timothy Unkert. The purpose. Okay, so we're going to demonstrate encapsulation, which is making sure private data is hidden from users. Okay, I want to make another note that this is good practice and promotes better security. Okay, and then I'm just going to put the date, which is the 2nd of November. Okay, and end my comment there. All right, so we're going to include IOStream. Okay, and I'm going to create a class called student. So I'm going to say class student. And what I'm going to say here is we're going to declare, or we're going to encapsulate some private data, which is their GPA. Okay. All right. But if we want to be able to alter it publicly, we can use a getter and a setter. So for the getter, for the setter, and my comment's all wrong here. I'm going to create a function called void set GPA, and we're going to say double G, and we're going to say GPA equals G. Okay. Now for our getter here, we're going to create a method that actually returns a double. So we're going to do double, and it's going to be get GPA, and we're going to return the GPA. Okay, so this is how we can use getters and setters, or setters and getters to deal with private data. Okay, I'm going to go up here and just say that we're using the standard namespace. Okay, I'm going to go down here and create my main method, main function. We'll return 0 at the end of that. We're going to make a student. We're going to name him Biff. Okay, so student Biff, and we're going to set his GPA. So we're going to do Biff. We can use a setter, set GPA. He's going to have 0.1 for his GPA, and we're going to say something. We'll make a comment, poor Biff. Okay, and then we'll do a character output and say, this time we're going to use the getter. So we're going to say Biff's GPA was set at, we're going to do Biff dot get GPA, that method, and then by the university. So we set it at that level, and do a new line character here. And let's save this. Open up the terminal. We're going to do G++ and then 050 because we're doing encapsulation. And let's run the output file. And so we see Biff's GPA was set at 0.1 by the university. So we've encapsulated the GPA, but we've also made it available to be altered with a getter and a setter. Okay. All right, so that was encapsulation. A brief look at encapsulation there. Now we want to talk about inheritance. Okay. I'm going to create a new file. Let's save it as 051 underscore inheritance.c++. Okay. And let's make a comment. Say the author, Timothy Unkert. The purpose of this is to demonstrate inheritance. And that's basically, it's when a class inherits from another class. We'll show you what that means in a moment. And then the date, this is the 2nd of November. Let's close this out. Okay, so I'm going to include my IOStream header file, and I'm going to say that I'm using the standard namespace, and I'm going to create a class. Let's call it animal, and we're going to have some public methods here. One's going to return a string. It's going to return a string called run because we included the standard namespace. We can do this. We're going to return the animal is running. Okay, and we'll put a new line character at the end of that string. We're also going to have a string called hunt. Okay, and we'll return the animal's hunting. Okay, do a new line character there as well. And we've got to put a semicolon at the end of this class. Okay, and now we're going to create a class called cat that inherits some of the methods from animal. Okay, so we're going to say class cat, and then a colon, and then public animal. Okay, and then we'll create some public methods for the cat, and we're going to have one that returns a string. It's a method called meow, and we're going to return meow like so. Okay, and have a semicolon here. Okay, so now we can go into our main method here, and I'm going to create, first return 0 here at the end. I'm going to create a cat, an instance of the cat class called Freddy. Okay, and what I'm going to say here is I'm going to do character output. I'm going to say my cat Freddy likes to go, and we'll do Freddy dot meow. Okay, and we'll end the line here. And we can also do a character output and do Freddy, and we can take some of the animal classes. So we could do Freddy.run, and we could also do Freddy.hunt. Okay, we could output those as well because it has inherited from that animal class. So it has its own method meow, but it also has access to run and hunt. Okay, so let's open up a terminal here. And we'll do G++. We're at 051 inheritance. Okay, we'll run the output file, and we'll say my cat Freddy likes to go meow. And we also have the animals running, the animals hunting. Okay, so we can have access to those methods that are in the class, the cat class inherited from, which is animal. Okay, hopefully that makes some sense. All right, next thing we're going to talk about is polymorphism. Okay, so we're going to create a new class. We're going to call this, let's see, what am I going to call this? 052 underscore polymorphism dot C++. And I'm going to do a more C-type comment here. I'm going to say the author is Timothy Unkert. The purpose is to demonstrate polymorphism. And that's when classes are related by inheritance and use the same methods but slightly differently. Okay, so I'll show you what that means in a moment. Okay, so I'm going to include my header file, IOStream here, and I'm going to be using the standard namespace. And let's create a class. We'll call this class cat, and we'll give it a public method which returns a string called cat sounds, and we'll return rear. Okay. All right. Cool. So that's our cat class. Now we're going to have a class, we'll call that lion. and this is going to inherit from the cat class. So, and this is going to have a slightly different method. So we're going to have, oops, I don't know why I did that. We're going to have a method that returns a string. It's also going to be called cat sounds, but this time it's going to return roar. Okay. We're going to have another class called kitten, which is related to the line class by inheritance. Right? We're going to have it inherit from the cat class, and it's going to return the cat sounds method, but it's going to return something slightly differently. So it's going to return meow. Okay. All right. And so now we can go and create our main function. And we can create a kitten. We'll call the kitten class, or the instance of the kitten class Freddy. And we'll have an instance of a line cat class called big cat. Okay. And we can do a character output and say, our kitten Freddy makes the following sound. And we're going to do Freddy dot cat sounds and end it with a new line here. Okay. And we can also do a character output and say a lion makes the following sounds. And we can do big cat dot cat sounds and do a new line character here. And let's see what's going on. Is there an issue? Cat sounds. Cat sounds is private. There's one thing I forgot with both the class line and the class kitten is I have to declare public. Remember what I said, classes are private by default, so I have to do the public keyword here. That's some linting telling me, hey, you need to fix that. Okay, so we're going to open up the terminal here, and we'll do G++ 052 polymorphism, and we're going to do our output file. And we'll say our kitten Freddy makes the following sound, meow. A lion makes the following sounds, roar. Okay, so that's polymorphism. Next thing we're going to talk about is writing to a file. So let's clear out some files here. And let's create a new file. And we're going to call this 053 underscore writing to a file.c++. I'm going to make my C style comment here. Say my author is Timothy Unkert. Purpose is to demonstrate how to write a file in C++. And the date is the 2nd of November. All right, we're going to include 2 header files here. So we're going to include our typical IOStream, and we're also going to include a file called fstream. Okay, and that's going to help us write 2 files. We're going to declare that we're using the standard namespace here and create our main function, which of course returns 0. Okay, so we're going to create an instance of the OFStream class. So that's the OFStream. You can think OFStream as output stream. I'm going to call that my file. Okay, and this is creating an instance or an object, an instance of the OFStream class, which is included in the fstream header file. Okay, so we're going to say my file dot open, and we're going to create a file to open, and I'm going to call it myfile.html. we're going to write to an HTML file. So this is going to create a file called myfile, or my-file.html in this same folder. And now we're going to write a couple lines to it. So I'm going to say my file, and to write, I'm just going to do the two less than symbols there. And in quotes, we're going to write what we want to write. So I'm going to do the doc type declaration. If you're familiar with HTML, so it's going to be doc type HTML, and close out the brackets. Then do a new line character. Then the HTML tag itself. Another new line character. I'm going to tab in, so I'm doing a tab character. Then the opening head tag. Then a new line character and two tab characters, because we're going to tab in, and I'm going to declare the character set. So the character set, I'm going to do an escape character, so I can put quotes here. I'm going to do UTF-8, another escape character, so I can close out the quotes, close the brackets. We're going to do a /n for a new line, two tabs there, and we're going to do the title tag, okay? And I'm just going to call it my web page. Close out the title tag, and we'll do a new line character there. Okay, so now I'm going to create another line. We're going to keep writing here, and we're going to tab in and close out the head tag, and then do a new line character, a tab character, and create the body opening body tag. Then do a few new line characters and a tab character, close out the body tag, and a new line character, close out the HTML tag, and a new line character. And that's that. And then at the end here, we're going to do myfile.close. So we'll close it out so there's no, so it shuts it off. There's no memory leaking anywhere. And let's compile and run it. All right, so I'm going to do G++ 053, writing to a file.c++, and then we're going to output, or run the output file. So that ran, okay? So now let's close this out, and let's open up the side here, and we see we have this myfile.html, and we can open it, and we've got this HTML file that we created. Here's the two new line, well, there's a new line here, and then the two other new line characters. We've tabbed in the appropriate spots. We have my web page and the title tag. So that's how we can write to a file using C++. Pretty cool, right? Okay, next up, we're going to do reading from a file. Okay, so first off, I'm going to create a sample text file here. Okay, so let me close out the sidebar. We'll create a new file. I'm going to save it as sample.txt. Okay, and I'm just going to write 4 lines. I'm going to say this is a sample text file. My name is Timothy Unkert. I am a teacher. Are you my student? Okay, and we're going to save that. And now let's create a C++ file. And we're going to call the C++ file. It's going to be 054 reading from a file.c++. I'm going to make my C style comment. So I'm going to say the author is Timothy Unkert. The purpose is to demonstrate reading from a file. The date is the 2nd of November. And I'm going to include the IO stream, or input output stream header file, and I'm also going to include the F stream header file. I'm going to indicate that I'm using the standard namespace. Okay, and then let's create our main function. Okay, so we're going to create a string to store the information that we read from the file. So I'm going to call that string, and it's going to be my read text. This is the name I'm giving it. You can give it whatever you want. And then we're going to create an instance of the ifstream class. So you think of ifstream, I think of it as input stream from a file. Okay, I'm going to call this my file. I like to think I for input, O for output. Okay, all right, so we're going to do my file and then the file we want to read to. So my file.open, and it's in the same folder. We're just going to type sample.txt. And then I'm going to say while, and I'm going to use getLine. And then I'm going to have my file, the file I'm reading from, and then the string I'm writing to, my read text. Okay, while that's happening, I'm going to do a character output of my read text. Okay, and at the end here, we're going to close it out. So we're going to say my file.close. Okay, now if I go and compile and run it as is, you'll see something, I don't want to do that one. Sorry. I want to do, let's just go and do 054, hit tab. Okay, so I want to do this one. And you'll see here, now when I run it, it says, this is a sample text file. My name is Timothy Unkert. I am a teacher. Are you my student? And then the prompt. So everything's on the same line. What I can do is if I go back to this file, is I can just include a new line character right here. And that'll format it a lot nicer. All right, so I'm going to go, I saved that. I'm going to go recompile it, rerun it, and we get the lines from the sample text file. So this is a sample text file. My name is Timothy Unkert. I am a teacher. Are you my student? That's what we wrote in our sample text file. That looks a lot nicer. Okay, to end up this mega tutorial, we're going to talk about exceptions. So this is the last file we're going to talk about, unless I had more. And it's going to be 055 underscore exceptions .c++. And I'm going to say that the author is Timothy Unkert. The purpose is to demonstrate try and exception. And the date is the 2nd of November. Okay. I'm going to include my one header file, just iostream here. I'm going to be using the standard namespace. And let's create our main function here. So I'm going to create my main function. I'm going to say some integer n is equal to 7. So I've declared and initialized that integer. And I'm going to create an integer UI. That's for user input. That's the abbreviation I came up with. I'm going to do a character output and say, guess the magic number. It must be a positive integer. Do a new line character there and close out that statement with a semicolon. All right, so now we're going to have a try block. So this is how we handle exceptions. So we can do try, and then we're going to take in the user input. And I'm going to say if the user input is less than 0, we're going to throw the user input as an exception, okay? And we're going to catch the user input. So I'm going to say catch int UI. Let's bring this up a little bit. And I'm going to do a character output and say UI, and then is not a positive integer. We'll do a new line character there and a semicolon. After the catch, we're going to check to see if they guess the magic number, right? So we're going to say if UI double equals n, well, then we can do a character output and say you guessed correctly. Okay, and do a new line character here. Otherwise, we're going to do a character output. Bummer, you did not guess correctly. I'll do a new line here. And we'll return 0 at the end of this main function. All right, so I'm going to open up the terminal here, and we're going to compile. This is the 55th file, and run it. And when it gets the magic number, I'm going to put -2. It's going to say -2 is not a positive integer, and then it also runs the bummer, you did not guess correctly. Now, if I run it again, and I guess, say 5, which is not the correct number, it says, bummer, you did not guess correctly. So it doesn't run the exception. And now if I run it again and just type 7, you guessed correctly, okay? So that's handling exceptions in C++. Okay, so this comes to the end of the mega tutorial. I hope I've gotten you a good start in C++, demonstrated that you can basically, run C++ programs in an IDE, or you can use a text editor and compile via the command line. This is a good start. I mean, to master C++ would take years and years. So hopefully it gets you off on the road to starting C++ in a fun way for you. If you found this video helpful, please give it a like, please share it, and please consider subscribing, as it really does help the channel grow. I want to thank you for watching, and I hope to see you on the next one.